There's a couple things that tell us that the heliocentric model is correct. The first is called Foucault's pendulum. Most of you have probably seen this before. It's in the lobbies of most museums. It is a giant pendulum that swings along a north-south line and is suspended from the ceiling. And as it swings back and forth, there are some pegs on the floor. And since that's fixed to the earth, those pegs are rotating. And as it swings back and forth, it will knock down those pegs. And it should do it at the same times. So we know that Earth's rotating at those values, those 15 degrees every hour, because every hour it will knock down a new peg. This is also called the Coriolis effect, which is inertia acting on a rotating planet. So our winds curve to the right. In the northern hemisphere, winds come from the equator and bend towards the right, in that case the northeast. In the southern hemisphere, they bend to the right, in that case the southwest. It's why we get weather systems from our west. It's why hurricanes eventually will come up the east coast. So the winds will eventually curve. Since we didn't do weather and climate, didn't see any more about this. But these are just evidence of the heliocentric model and that Earth is rotating. This here is the Foucault's pendulum. It'd be hanging from the ceiling, and it'll swing back and forth, knocking down the pegs. As I said, many of you have seen this before in museums. This is what it can look like, and you actually can make your own. And if you can hang it somewhere in your house, you can figure this out yourself. But usually most museums have them, but you just see to walk by it, you have no idea what it actually means. This is the museum version of one. You have the giant pendulum, and then you see there's this spike on the bottom, and it'll swing back and forth, and every time it passes and hits one of these markers, it will knock them down, and this happens every 24 hours. All these will be knocked out as it swings back and forth. So some of you might have seen it in museums. They're kind of boring to watch unless you actually hit like every hour on those, or depending how many pegs they have set up. But this is what those indicate, that the Earth is rotating at a constant interval. Now, how the sun moves does play a factor in our daily lives. Our system of time is based on how the sun appears to move through the sky. Remember, the sun is not moving. We are moving. But this apparent movement is what determines a lot of things. So, the objects appear to be moving, but really aren't. That's an apparent motion. That it looks like the sun moves across the sky, looks like stars move and the moon moves, but they're not really moving. This gives us apparently a solar day and an apparent rise from the east to the west. A solar day is sunrise to sunset, which changes depending on what seasons we're in and how we're facing the sun and the angle of the earth. Solar noon is the time when the sun is highest in the sky. So 12 o'clock, noon. If you go outside, well, that's when you see the sun highest in the sky. However, this isn't the warmest time of day. That's usually 2 to 3 p.m. But the highest sun, no matter where you are on Earth, will be at 12 p.m. So once again, our movement, we rotate on our axis. And it's 24 hours long for one rotation, one day. And that gives us day and night. Since the Earth is rotating and the sun is at a fixed position, we're rotating into the light or away from the light. We revolve around the sun, 365 and a quarter days. This gives us our seasons. And Earth is tilted on an axis. We're at 23.5 degrees. You have seen this number before, because this is the latitude of both the Tropic of Capricorn and the Tropic of Cancer, at 23.5 degrees north or south. So that tilt does play a role in the tropics. And remember, those numbers are given to you in your reference table. So our seasons, once again, are from the tilt of the Earth at 23.5. As Earth revolves on the sun axis, because we are tilted, different things are affected differently. So we get different amount of sunlight. We are further closer from the sun at different seasons. So June 21st, this is the summer solstice, the first day of summer. Our northern axis points to the sun. So Earth and space, the whole axis is why all the globes we use in class are tilted. Well, that tilt will be pointed towards the sun. The sun is overhead at 22.5 north, which is our Tropic of Cancer. And at the North Pole, the sun appears to move in the circle around the horizon. The sun never really rises or sets. It's when they get 24 hours of sunlight at the North Pole. But it's not in the sky, it's on the horizon and moves around in a circle. Then we have both September 21st and March 21st, sometimes the 22nd. These are the autumnal and vernal equinoxes, or the fall and spring equinoxes. At this point, the sun is overhead at the equator. So it's directly overhead 90 degrees at the zenith. The sun moves in circle the horizon at both poles. So the north and the south pole, the sun moves around in circles. Everywhere on Earth, on these 2 days, has 12 hours. So 12 hours of sunlight, 12 hours of darkness. The sun rises due east and sets due west. Any other time of the year, the sun doesn't rise directly east. Usually here in New York, it rises from the southeast or the northeast. But on east, it only happens on these days. December 21st is our winter solstice, first day of winter. And this is our northern axis pointing away from the sun. And the sun is overhead at 23.5 degrees south. So it is the opposite of the summer solstice. This is why the southern hemisphere has different seasons. Because Earth is tilted towards the sun in our summer, we get more insolation, more sunlight, which gives us warmer temperatures. When we're pointed away from the sun, because of the curves of the Earth and we're round and we're pointed away, we get less sunlight, therefore it is colder. So our seasons and the temperatures of the seasons all depend on how much sunlight we get. Because the longer you heat things up, the hotter it gets. If you only heat something up for a short amount of time, let's say 9 hours versus 15, well, those 6 hours make it different. You have all the energy from the sun affecting it at once. Now, a common question is, what happens if the movement change? It will never change, but if it did. If our rotation slowed down, we'd have a longer day. Because our rotation now gives us 24 hours. If it slowed down, as some planets are, their days could be roughly 40 hours, 50 hours. In some cases, they're quicker. They are about more like 12 hours. Venus has a day that lasts 247 days. Their day is longer than a year. And if we had a longer day, more sunlight, it'd get even hotter during the daytime, even colder at night. If we had a higher tilt, so instead of 23.5, we'd have 30, 35, 40. We'd have warmer summers and colder winters, because we'd have access to more sun in the summer and less in the winter. So we are actually at the perfect rotation and revolution and tilt for life. If this was to change, it would definitely cause the extinction of humans as many other species on our planet. Now, yes, you might hear that the axis tilt does change. Instead of 23.5, it might be 23.4 to 23.6. But that wobble is common and doesn't have that much of a change. Now, the unusual thing about our movement on the sun is the northern hemisphere is actually closest to the sun in the winter season. We're further away in the summer. Yes, it is warmer and hotter in the summer, but we are not that much different. We're only talking maybe a few hundred kilometers. So, even though we are closer in the winter, that's not going to make us hotter, because so much energy is lost in space. So, our temperature is not determined by how close or far we are from the sun, it's how much daylight the planet gets on that region at that time. So here is a picture of that. The sun's in the middle, and the picture on the left, this is summer. You see, this is the northern pole, and it's pointed towards the sun. On the summer, it is pointed away from the sun. And if you look at the mid-season, spring and fall, well, this is summer here, this is our winter. Okay, and that's red. This is winter. So, if you know when winter and summer are, and that's really horrible writing of that, well, the one on top, go from winter to summer, that's the spring. The one on the bottom has to be fall. So to determine what seasons are based on the pictures, figure out which one is summer first, then winter next, and then you can figure out the other two seasons. This is it for today's slides. You have 15 questions on Castle Learning Tonight due for homework, due in a week, just based on what you saw today. 15 questions are very basic, use these notes, almost nothing's reference table, so it should be fairly simple.